All right, we're going to go ahead and get started and kick off our evening. So, welcome everyone. Thank you for joining us for Exploring Machine Learning with Yes. My name is Kendall Brinson. I am a professional learning and outreach manager with the Youth Engineering Solutions team. So, I just want to go over our goals for tonight. So, we're going to look at how students can meaningfully engage in machine learning in ways that are hands-on, age-appropriate, and deeply connected to the engineering work that they already do if they're using a YES unit. We'll explore the two YES computer science modules that introduce supervised machine learning, which are photo classification for upper elementary students and user reviews analysis for middle school students. We'll talk about what machine learning is, how it's used in these modules, and how these activities support the YES computer science framework. And this session is recorded, so feel free to sit back and follow along, and we'll go ahead and get started. So for anybody new here, you might be wondering what is YES? So YES, or Youth Engineering Solutions, is the Museum of Sciences in Boston's pre-K to 8 engineering and computer science curricula. At the core of YES is the belief that all students can meaningfully participate in engineering when they're given authentic, socially connected challenges that honor who they are, their developmental stages, and that is a key part of who we are. So, why are we combining engineering and computer science? Well, a key part of engineering today does involve using computational tools. Engineers rely on tools like sensors, simulations, machine learning models to work more efficiently, more accurately, and with better insight into complex systems. And the YES computer science framework shown here on the screen reflects this and provides the basis for all of our computer science modules, and it focuses on three key big ideas. One of which, in the purple, is increase efficiency and accuracy, which just means we're using these computational tools to extend what humans can do. Maybe we can do it faster and more accurate. The second in the blue is generate and use algorithms. We understand that coding and algorithms are a key part of computer science, but we want students to understand how computers follow instructions and identify patterns with this particular domain. And last, but certainly not least, is in the red, recognizing social context. And this means that we want students to consider bias, fairness, and real-world impact of technology by engaging in our computer science modules. And these domains are also the building blocks of AI literacy. When students learn that computers don't think like people do, that humans choose the data, training data that goes into these models, and that outputs have to be checked for sense making, morality, etc., they begin to build the habits of mind that are really needed to engage with AI responsibly. So, what is machine learning? Before we dive into the modules, we should probably talk about this part. Machine learning is a type of AI where the computer learns from examples rather than step-by-step instructions or other sorts of algorithms. So instead of telling a computer exactly what to do, we show it lots of examples and it figures out patterns and then can guess and make assumptions from there. So by engaging in machine learning, students will learn that machine learning requires a set of training data. The computer is looking for patterns, not meaning or context. The quality and variety of training data matter a lot, and that human oversight is always, always important, and that computers shouldn't make decisions alone. So this understanding really sets students up for the modules I'm about to talk to you about. So we'll start with machine learning in elementary school. So this comes from our engineering plastic filters unit, which is for an upper elementary classroom. It is designed for fifth grade, but can flex. And its companion computer science module, which is called Photo Classification, which uses Google's Teachable machine, which is available for free use online. Let me provide you with a little bit of the context that sets up this computer science module. So this is coming from our engineering plastic filters unit, and students begin this unit by investigating a real-world environmental problem. So they are introduced via a comic book, and they meet Kayla and Antoine, who are two characters who live in Mobile Bay, Alabama, and they notice a problem that their local bay is polluted with a lot of plastic trash, and the unit follows the engineering design process for 9 lessons that take about 45 minutes each. They work as environmental engineers in this unit, and they learn about plastic pollution, its impacts on local ecosystems and different groups of people, whether that be a grocery store owner who has to raise prices or a boater who can't move their boat through lots of plastic in the environment, or the animals that are getting sick. Then they design and build plastic filters that can fit into a model bay using a set of criteria constraints, including a budget, and making sure they're using materials that will maintain themselves in water. They test how well those filters catch pollution, and then they improve their designs using the engineering design process. So by the end of the unit, they've created and refined a filter for just one polluted waterway. And then they start to connect this problem to the real world. It's not just something happening in the story. Plastic pollution is very real, and it affects other areas across the globe. And the photo classification computer science module picks up right there. Is there another body of water that also needs a plastic filter? And how would we know? And to help answer that question, they use a machine learning model to analyze photos from a stream. So what you need to know before I walk you through photo classification is that the machine learning doesn't replace the engineering, it's extending it. The students are going to use these computer science tools to inform their engineering decisions from engineering plastic filters. So let me introduce you to photo classification, one of our newest computer science modules available to you. So the photo classification module, of course, is attached to plastic filters and is optional, but students are helping to determine whether a creek near the bay should also get a plastic filter to prevent trash from entering more waterways and this particular creek. The module spans 3 lessons that take about 45 minutes each. They begin, just like in plastic filters, by setting the context using a comic. And the comic follows Kayla and Antoine, that same brother and sister duo from engineering plastic filters. And in this case, they meet Carlos, who invites them to test his machine learning model that's not quite ready yet. And the goal is to use the model to determine if this creek needs a plastic filter. And they're asking, can the model successfully sort images between what is trash and what is an animal? And students start this particular lesson by sorting the photos on their own. Usually, this is pretty easy for students. They feel really confident that they can identify these images very quickly. This is an animal and this is trash. Then they test the simple machine learning model that tries to classify them as well, and they might notice some things. So I'm going to play a quick video that shows how they're using Google's Teachable machine in this context in the unit.
Divide up Kayla and Antoine's photos so each group member has some photos to test. Hold up one of the photos. Position it so that only the image on the card shows on the computer screen. Look at the computer's guess. If the computer guesses correctly, circle the thumbs up on the computer's guesses. If the computer guesses incorrectly, circle the thumbs down. Repeat for all your photos.
All right, so you get a sense that the students are holding up these photos to this machine learning model, and they start to notice things. As they explore this model, right away they start to see mistakes. The model might confuse a turtle for trash or a plastic container for an animal. So for example, I have some screenshots here from Google's Teachable machine, and you can see it's very confident about the fish in this photo. They 100% know it's an animal, and they're very confident about the soda can. But it's a little less confident about the boot in the water and has a little bit of a percentage under animal, and it completely misidentifies the mask as an animal. And this sparks an important realization for students. They begin asking why the computer might be making these decisions. And they begin to realize that They themselves, as people, as humans, have prior experiences that form their knowledge of what an animal is versus what trash is, and a computer doesn't have the same type of knowledge. From there, the students actually get to dig into the training data, which is the set of images the model was originally shown. The computer is using this training data to teach itself how to classify the animals in trash. They look at what kind of animals are included, what kinds of trash have been labeled, are there colors and shapes that dominate the set of data here, and what is missing. And this connects the misclassifications to the training data itself. They might think, oh, the model has a lot of blue animals and blue trash, so it might confuse those. Or, as you can see in this particular data set, it's only seen fish, so it might confuse other types of animals. So, as they start to recognize some of these patterns, students do an unplugged offline activity exploring the similarities and differences in a set of photo training cards so they can start to identify patterns in shape and color, some of those characteristics for animals versus trash. And they learn that the computer uses those types of characteristics to classify the images, not prior knowledge like humans do. So using the patterns a computer does, they sort the cards themselves, which have animal patterns, which have trash patterns, or both. So I have an example on the screen. So this is a duck image, and it has characteristics that fit squarely in the animal classification. It has mostly curved edges and is primarily brown. So the computer probably thinks, hey, this is an animal, pretty easy. But if we look at the other examples, like the plastic bag, it has both an animal characteristic, curved edges, and a trash one. It's mostly whites and reds. So quickly, students start to understand why a computer might mislabel certain images. This activity helps students understand how our computer actually uses these patterns to classify photos of animals and trash. And the computer finds patterns in the training data, such as these shapes or colors. And the computer uses these patterns to classify new photos. So it's really giving them an understanding of the machine learning that this model is actually doing. Then, as they recognize that there are some errors and they might want to make some changes, students act as computer science to add to the training data, train it, and test their computers to improve Carlos's machine learning model. Students look through various images and they can add more diverse ones that include animals from different habitats, trash from different angles, or images with varied lighting and color. So I'll play this video for you of what that looks like in Google's Teachable machine.
Groups will train and test the computer in 3 rounds. For each round, the whole group chooses 3 training photos to add to Carlos's training data. When the group is ready to add training data, the trainer clicks on the webcam button under Trash to add more images of trash, or under Animal to add more images of animals. The photo holder holds up a training photo to the webcam so that only the image on the card is visible to the camera. The trainer clicks on Hold to Record until the image appears in the computer's training data. It's okay if the same image appears more than once. Just click on the trash can icon to delete the extra. After adding a photo to the training data, the photo holder puts it back in the bag so it won't be used again. Once all 3 training photos are added, the trainer clicks Train Model. Wait while the computer finds patterns in the training data. To test, the whole group will bring the trained computer to the test station. The photo holder and the trainer take turns holding up Kayla and Antoine's photos to the webcam so that only the image on the card is visible to the camera. The recorder circles the computer's guess for each photo on the computer's guesses. As a team, review the results. Discuss which 3 training photos you will add in the next round. Can you improve the training data so that the computer guesses all of Kayla and Antoine's photos correctly?
So as you can see, students would be holding up images or uploading them into Google's Teachable machine through 3 rounds. And this step really reinforces one of those key AI literacy ideas that training data really has to be thoughtfully assembled. They can only add 3 images at a time and look at their results and use those results as evidence to make decisions for their next set of training data. Also, it reinforces that better and more representative data will lead to a better performance of the machine learning model. So as in the video, you saw students retrain the model with the improved data set and run the same set of images through it again. And one of the fun parts about this is that they can see accuracy improve almost immediately. And this is the moment when students realize that the computer only knows what we show it. And this understanding that machine learning models reflect the data they're trained on, again, is foundational for AI literacy later in life as they explore more advanced tools in the future. And finally, students use this improved model results to help answer that engineering question. Does the creek actually need a new plastic filter? And they return to the comic to learn that their improved machine learning model helped Carlos's model be more accurate, and that the creek does need a plastic filter so they can actually make changes to their environment. And they see how machine learning can be a powerful support tool in engineering, but only if it's used with care, context, and good data. And this reinforces that machine learning isn't magic. It's a tool that depends on humans making thoughtful choices. And then they also start to connect to how training data and machine learning also affects how they interact with technology in their daily lives. They think about Siri suggestions, Netflix suggestions, video games, all sorts of apps on their phone, and how their own preferences or things they click on are training algorithms that give them suggestions or ads, and that they can be more thoughtful users of these tools in the future. With that said, that wraps up our upper elementary unit and computer science module. So now we're going to do a walkthrough of machine learning in middle school with our engineering eco slippers unit and its companion computer science module, user reviews analysis, which uses MATLAB by MathWorks. So again, I'm going to set the context for you here with the engineering. So in the eco-friendly slippers engineering unit, students actually act as product engineers for a slipper company. And their challenge is to design slippers that are safe and provide good traction, are comfortable to wear, and of course, are eco-friendly, that use as many materials as possible that reduce the environmental impact. So students throughout this unit are researching different materials and their trade-offs, like this is eco-friendly, but it's way more expensive, so it will be really hard to sell later, for example. They also build and test slipper prototypes and test for traction and comfort. And of course, they iterate on their designs to better meet the criteria and constraints. At the very end of the unit, they actually do a worksheet on bringing their product to market. How much you're going to pay your workers? How much does this slipper actually cost? And once their slippers have been released to their customers in the story, that's where our user reviews analysis unit comes into play. They receive a set of fictional user reviews, and these reviews describe what people liked and didn't like about the slippers. And students in this particular module use a machine learning model to help analyze the reviews so they can decide how to improve the next version of their slipper. Again, the computer science work is grounded in the engineering, and they're using machine learning as a tool to make better decisions about their product, and it's not isolated from the engineering. So let's walk through user reviews analysis together. Like in photo classifications, they're shifting from designing to computer science, and in this case, they're interpreting customer feedback using MATLAB Live Scripts, which are a controlled set. It's a programming arena for you to play in, if you will. And this module spans 2 lessons that take about 45 minutes each. So they start by reading fictional reviews and labeling them as positive or negative. I'm going to play a view of what this live script looks like. In lesson one, they're labeling those reviews. Once they're loaded, each group gets 6 reviews to label, and they'll have 3 to 5 minutes to label the reviews. So some of them are quite easy to label. If it says great traction, awesome, pretty easy to label as positive. But not all the reviews are super clear cut as positive or negative. For example, they think the slippers might be dangerous for some people. You might label that as unlabeled. But once everyone is done with labeling all 6 of their reviews, you come back together as a class to do section 2, where you review the amount of time it took to review all of these as a whole. So it only took about 1 minute for me to sort the reviews. So if there was 8 groups, that would be 8 minutes to sort 48. But this allows you to estimate how long it would take to review hundreds of thousands of reviews. As you can see, it would take quite a bit of time, 277 hours. And I'll pause here for a second to say that students recognize that a computer in this particular live script might help make this task more efficient, and it would take a really long time for us as humans to review these by hand. And then in section 3, they discuss what made them actually label these reviews as positive or negative. And they might discuss how they relied on tone, connotation, context, some of the nuance. They might not use these words exactly, but they are looking for those adjectives and some of the context of these reviews. And these are, of course, abilities that a computer simply doesn't have. We explain to them that training a computer to recognize positive and negative reviews begins by giving the computer reviews that have already been labeled by a human, and that this particular set of data is called training data. And the computer uses the training data to identify patterns among the positive and negative reviews, and it will use those patterns to guess if a new review is actually positive or negative. And this is exactly what machine learning is. So then the students will run the same reviews through a machine learning model to identify patterns in language across the positive and negative reviews. And as you can see, the model gets some of them wrong or even duplicates words between the 2 categories because they're repeated multiple times. So there's 2 histograms on your screen showing you the frequency of words between the positive and negative reviews. So as you can see in the little table on the right, the word I is duplicated between positive and negative reviews, so that could confuse a computer. Then there are words that don't stand out as particularly positive or negative, like my or they. And this leads to a comparison between human and machine reasoning. And students start to understand that they as humans can understand context and meaning. And the machine learning model is only looking at the word frequency and not the meaning or understanding of those words. And this helps students see why certain words might mislead the model, or how machine learning with text is a lot more abstract than an image classification as you would do in photo classifications. Now they're introduced to the idea that the algorithm can be modified to remove the words that are common to both lists. And they run the same reviews through a machine learning model again. In this particular live script called removing overlap, the algorithm actually instructs the computer to remove words that are common to the positive and negative reviews in the training data. And they learn that they can train a computer to label reviews by providing it with training data that has already been labeled by a human so it can look for patterns and make guesses about the new data. So as you can see at the bottom here highlighted in our red square, we notice that there are inaccuracies in the computer's guesses by comparison to the human label. So in this case, the computer only guessed 15 of the 29 new reviews correctly, which means almost half of the computer's guesses are incorrect at this point, which means we might have to do some work. So because the model did not always guess correctly, students consider how they can improve the accuracy of the computer's guesses in lesson 2. More reviews can be added to the training model, especially ones with more complex language, and they retrain the model and evaluate the changes in accuracy. So you can see what this looks like in this screen recording here. So the number of reviews, I've increased it all the way up to 140, the highest number. I've loaded them out. How often should a word appear before the computer pays attention to it? I change it to 8. You can see the histograms like before showing how many times a word is repeated. And just like before, students are able to remove the duplicated words. You can see a list of the positive words that they've chosen, the negative ones, and the common ones. So it will pull out the common and duplicated words. And then they can fine tune this algorithm by adding or removing words that the computer should or shouldn't pay attention to. And so this is what student work might look like, though not as quickly as mine, I assume. So you can scroll down and read all of the reviews and see how the computer versus the human actually labeled them. And then you can see me sort of quickly removing general words that are not as descriptive, like a, was, when. Some of these words, of course, are not super helpful. And also at the bottom, it starts at 19 of 29 reviews correct. So as I'm removing these words, I could check the accuracy each time, as you might encourage students to do as they continue to add and remove words. And as I continue to remove several words, I will go back down eventually to check to see how much I was able to increase the accuracy. So scrolling back down, you can see my list of removed words and how well did the algorithm work. I've gotten up to 20 of 29. I'm feeling confident, but I would like to add a few words for the computer to pay attention to. So for example, I recognized traction in part of the reviews and it became positive, and now I'm up to 21 of 29. And again, you would review lots of the reviews to say, okay, which reviews is the computer still getting wrong? Are there common words that I should have the computer pay attention to? So I'm scrolling, I'm reading, I'm walking myself through, and students would do something similar. I noticed that somebody said they slipped in their slippers, so I go back and I add the word slipped eventually. We will get there. And so finally, I add the word slipped, and I'm able to get the computer to guess up to 22 of the 29 reviews correctly. Now, they can continue to play with this and recognize that the frequency and other things might need to change. So they realize that sometimes improving a model means adding better examples, like telling the computer to ignore some of the words like I mentioned and showed in this video, like and, to, was, when. These are not helpful to the computer. And giving the computer more reviews, for example, that would lead to better guesses. I started at 140, not all students will. Or changing the number of times the word needs to be repeated before the computer pays attention to it. But sometimes it means acknowledging that the model also has limitations. And in this particular case, the live script was actually built to only reach about 80% accuracy total. And this actually encourages and forces that conversation about the limitations of machine learning models. They are not perfect and they need human intervention. And finally, the last step of this module, after they've improved the model as much as they can and reflect on it, they discuss the real world stakes. And this is the reflection activity page that is from lesson 2 that asks students, would they feel comfortable using this particular machine learning algorithm to label user reviews? Why or why not? Some may answer yes, 80% accuracy is good enough, or maybe it's not. And would there be instances where it's okay if machine learning produces inaccurate guesses versus instances where it wouldn't be okay? So now you have real world discussions of, say, you're using a machine learning model to predict the weather. Probably okay if you get it wrong if it's going to rain tomorrow. But if you're using a machine learning model to predict whether people will have a chronic disease, yes, you probably want it to be as accurate as humanly possible. So you have these real world connections that really deepen students' understanding and deepen AI literacy by connecting machine learning outputs to actual consequences, benefits, etc. And that wraps up our middle school machine learning model, user reviews, analysis. So now I just want to talk to you a little bit about the developmental progression and how these are age appropriate for elementary school students and middle school students. So first, photo classifications for upper elementary is perfect because it's visual, concrete, and highly observable. Students can see immediately what the computer misclassifies and why that might be happening. And this aligns really with how we think about young learners and how they make sense of the world today through visible patterns, tangible examples, something super concrete, and of course, immediate feedback. They see immediately how the computer is interpreting and what they're getting right and wrong. On the flip side, middle school students are ready for abstract thinking. They can reason more about tone and context and meaning, and they can critique decisions. And they're more prepared to discuss fairness, bias, and why a model might pick up on irrelevant patterns. And this is why text-based machine learning is more appropriate at this grade level. Now, together, these modules form a very thoughtful developmental progression. So elementary students work with concrete, visible machine learning patterns and images, and middle school students work with abstract, contextual reasoning with text. But both of them together reinforce the core ideas behind AI literacy, that AI learns from data, finds patterns, reflects human choices, and needs human oversight and intervention. Now, I do want to talk about how supervised machine learning, what students are doing in these particular modules, compares to generative AI tools like ChatGPT. I know that when we think of AI, we may not always consider machine learning directly, or live scripts, or these particular programming environments. Nowadays, we usually think of generative AI, but our modules are not the same. Artificial intelligence is really the broad field of creating these systems that can perform tasks that normally require human intelligence, like recognizing patterns or making decisions, producing language. And machine learning is just one approach within that. And machine learning, computer, like I said, learns from patterns in data and improves its performance over time without being explicitly programmed in every step. In short, AI is the big idea, systems that act intelligently, and machine learning is one of the methods inside of AI, systems that learn from data. So in our module, students engage with supervised machine learning that trains on labeled examples. So students are explicitly teaching a model what is an animal and what is trash in photo classification, and what is positive and what is negative in user reviews analysis. By contrast, generative AI is trained on enormous amounts of unlabeled text and information. It learns really deep patterns. It can generate new text, but not these types of classifications in this way. And this difference is not just okay, it's also really, really important. Supervised machine learning gives students the foundational ideas like AI learns from data, AI finds patterns, human choices matter, and outputs always need to be checked. And these are the exact concepts that we want students to have before they're exploring these more advanced AI tools like ChatGPT. So these skills are really foundational. And with that, why on earth do we care? Why does AI literacy matter before we jump in? AI is already deeply embedded in our daily lives, right? We know this. Recommendations, search results, spam filters, translations, using it to help them with their homework. It's already here. Students need grounding in how AI works so they can be informed users of these tools and better future engineers. AI literacy isn't a future topic, it's right now. And AI literacy really means we're helping students understand what AI is, how people design it, how to use it safely and ethically, and how AI can support, but not replace, their creativity and problem solving. So through our modules, we want students to walk away learning how to question information, recognize impacts, and use AI just as one tool within their broader engineering design process and within their life across other subjects. So these modules are designed to give students a grounded and meaningful, developmentally appropriate way to begin. All right. That was a lot of information. So I am happy to take questions in the chat at this point about either of the modules, or any questions in general, and I can hopefully answer for you. So we have one question here about classroom materials for these particular modules. These modules only require your students to have access to some sort of computer or device, and there is print materials associated with each one. So photo classifications has photo images that you can print off, but you can also use them digitally. So in photo classifications, in using Google's Teachable machine, there's an option to also upload images into the machine learning model. So there's some options if you don't want to print or don't have the ability to print off lots of images. Um, and same goes for user reviews. It is just print materials plus MATLAB, which is available for free online to use. Now, if you are doing these in accompaniment with the engineering, which we highly suggest, kits with the engineering materials can either be purchased on our website or you can source your own because the materials lists are available to you as well. Now, we have another question about how might the AI photo classification be scaled up? That is a very good question. This unit is brand new, so I haven't personally given a ton of thought to scaling up quite yet. But I'm happy to chat with you after or take a look at it or redirect your question to our curriculum team about scaling up for a higher grade level. So we have a question as well about adaptations for students who are already using ChatGPT and generative AI. I personally believe that our units are a good either introduction or a good stop and pause, let's think. So I don't think you need to make many changes. I think that these units themselves could help be very eye-opening to students that are already engaging in generative AI. You may have to explain to them the difference, sort of like I did at the beginning. Machine learning is a part of AI. It's just one subset. And the units actually introduce machine learning as a vocabulary term as they walk through. So that is a good way to either stop and pause when they're already using AI tools to help them better understand what's happening behind the scenes and build some skills. So I don't think you need to do anything crazy right now to make those types of adaptations. So there's a question about adapting for students with learning disabilities. I will say that that will wholly depend on what the learning disability is. Our units are designed to be accessible to all types of students, all types of learners, but of course, we can't predict all sorts of situations. So there are lots of different ways to engage, whether that's circling, writing, drawing, modeling out what's going on. So there's different ways to engage in the unit, but if you need specific supports, I definitely recommend you reach out to us about the specific disabilities you're working with, because we have quite a few partners who also work and adapt our resources for students with high support needs. So students do not need any accounts to access any of our resources at all. Google's Teachable Machine is free online. You don't need a password or login at all to utilize it. And MATLAB is the same. You do not need an account or anything else at all. Sometimes accounts are helpful because it helps you save from lesson to lesson, but you don't always need to save the data because there are engineering design notebook pages that support students to record their learning as they go. So these particular activities take various amounts of time. So the engineering units, both units I discussed today, plastic filters and eco-friendly slippers, are 9 lessons apiece that last about 45 minutes to 60 minutes, depending on your students. The computer science modules for plastic filters, photo classification is 2 lessons that take about 45 minutes apiece. And the middle school unit computer science module is 2 lessons that take about 45 minutes apiece as well. These activities were both designed for in-school sessions. However, you are welcome to use them in other activities in other places as well. We have lots of teachers who use them in camps and out of school, um, or, STEM weeks and things like that. So they are highly shiftable and adaptable and flexible for your different needs. Right. If you have any specific questions, I'm going to put my specific email in the chat. You can also find us online, which I will show you in a second. But my email, I'm happy as a professional learning manager to help you sort of navigate some adaptations or changes that you need to make, or if you have tech-specific support questions, we can also help you there. So one, if you'd like to explore this topic just a little bit more, we did have a recent blog published by Deepa Shah, our Senior Director of Curriculum, called Engineering Critical Thinkers, Integrating Computer Science and Engineering. You can explore that blog post as well as others on our website and, of course, subscribe to email updates. The other thing you should know is that you can find all our Yes Engineering Computer Science modules on our website at yes.mos.org. You can even do the computer science modules yourself. You don't need an account, and they're all free. So Google's Teachable Machine and MATLAB Live Scripts are free and open access, just like the rest of our resources. So teacher guides, engineering notebooks, teacher slides that are student facing are also available for you for free, all online. We also encourage you to view our upcoming professional learning opportunities. We are actually doing both of these units and the computer science modules in our upcoming workshops in 2026. So feel free to take a look, register if you're able. But if you don't see what you're looking for, feel free to contact me or anyone else about custom workshops and pricing and all sorts of things. And of course, last but not least, if you cannot make it to any of those workshops, we hope that you're able to visit our learning library that's also available on our website. There's self-paced resources that can help you refresh any sorts of engineering and education pedagogy. We have videos, all our recorded webinars are available there as well, and you can take a look and see what might be helpful. So thank you so much for joining me this evening. I am looking forward to hearing from you, and I'll hang out for a few minutes if anybody else has any more questions. But I appreciate you being here and for your thoughtful questions.